Okay, so let's look at practice quiz 4, number 3. It says for each differential equation, first show that y1 is a solution, then use reduction of order to find a second solution. So here's our differential equation, y double prime plus 25y equals 0. And we're given here that y1 is a solution. So let's first show that y1 is a solution, then we'll use reduction of order to find a second solution. So to show y1 is a solution, let's first look at the first derivative of y1. So note. So y1 prime then, derivative of sine's cosine, then be derivative of 5x would be 5. So it's going to be 5 cosine of 5x. Let's next find the second derivative. So doing that we get then, so it'll be derivative of cosine, which is negative sine, times derivative of the inside, which is 5, and there's 5 still in front here. It'll be 5 times negative times 5, so it'll be negative 25 in front, sine of 5x. Okay, now let's plug in two differential equation here. So doing that we get then, so plugging in we'll have y1 double prime plus 25 y1. So it'll be negative 25 sine 5x is my y1 double prime, and plus 25 times y1. So you can see when you add those you get 0, so it checks out. So we've shown that y1 is a solution. Now let's use reduction of order. So let me write the reduction of order formula here. So it's theorem 6. Okay, so here's the reduction of order, or theorem 6. It basically says if y1 is a solution of this differential equation, y double prime plus px y prime plus qx y equals 0, then y2 equal to y1 times this integral y1 to the minus 2 e to the negative integral p of x dx is also a solution. So let's identify what the p is in our case. So let me write our guy down here. So note. So in our case then we can write our differential equation up here. It doesn't have any y prime terms, so you can think of it as 0 y prime. So then matching it up with this general form of the differential equation over here, we can see that the p has to equal 0. Okay, so our y1 is sine of 5x, our p function 0. We can now plug into this guy here. So let's do that. So I'm out of space here, so I'm going to erase a few things and we'll keep going. Okay, so summarizing, we have our p is 0, our y1 is sine of 5x, and our y2 is given by this, our reduction of order formula. So let's plug into this guy here now. So doing that we get then, so plugging in we have this then, so we have sine of 5x, sorry, integral of sine of 5x to the minus 2 e to the 0 dx. E to the 0 is 1, and sine 5x to the minus 2 means 1 over sine x squared, and 1 over sine, if you recall from your trig functions, is cosecant. So let me write that here. Okay, so recall that 1 over sine is cosecant. So then here, this would be 1 over sine 5x squared, so it's going to become cosecant 5x squared. And now I'm going to make a substitution. I'm going to let u equal 5x. Let's do that. Okay, so I'm going to let u equal 5x, then du dx is 5. So solving for dx then, dx to be du over 5. Let's make that substitution over here. So doing that we get then, okay, so making a substitution then, we'll have our y2 equals sine 5x integral cosecant u squared du over 5. We can bring this 5 out over here. And also we can recall that the integral of cosecant squared is negative cotangent plus c. So making that substitution here we get then, so making a substitution we get then sine 5x over 5 times negative cotangent of u plus c. Now we can use the fact that u is equal to 5x over here. Let's put that here. And also we can choose c to be 0. So let's do that. Okay, so recall that negative cotangent 5x, well, cotangent is defined to be cosine over sine, so negative cotangent of 5x would be negative cosine of 5x over sine of 5x. So I'm going to replace the cotangent of u then with cotangent of 5x and replace it with this guy, and choose the c to be 0. So doing that, we'd have this then. Then you can see the sine 5x's cancel. So we get then negative cosine 5x over 5 should be our y2. Okay, so next thing. Okay, so y2 then equal to negative cosine of 5x over 5 should be a solution also. But here's an exercise for you guys to work on, so it's fairly easy to show. So if y2 is a solution of this differential equation y double prime plus px y prime plus q of x y equal to 0, you need equal to 0 here, then y3 equal to c times y2 is also a solution. So pretty much we can multiply our solution by any constant, and again it will be a solution. Again, the differential equation has to equal 0 for this to work, and it does in our case. So therefore we could multiply our y2 by, say, negative 5 to make it just cosine of 5x. So let me write it up here. Okay, so using this exercise in this example then, we got a y2 with this negative 1/5 in front. We can just multiply the y2 solution by negative 5. Let's call it y3, say. So multiplying it by negative 5 just become cosine of 5x. So cosine of 5x is also a solution here. Okay, so we're done with question A. Let's do question 3b in the next video. Okay, so let's leave it there.